The research paper presents an in-depth analysis of the intermediate polar IGR J15094-6649, utilizing archival optical data from the Transiting Exoplanet Survey Satellite, TESS, and X-ray data from Suzaku, NuSTAR, and the Neil Gehrels Swift Observatory. The analysis confirms and refines the previously reported spin period of IGR J15094-6649 as 809.49584 plus or minus 0.00075 seconds. A clear evidence of a beat period of 841.67376 plus or minus 0.00082 seconds is found during the long-term TESS optical observations, which was not evident in earlier studies. The dominance of X-ray and optical spin pulses indicates disk-fed dominance accretion. However, the presence of an additional beat frequency suggests that part of the accreting material also flows along the magnetic field lines. The energy-dependent spin pulsations in the low, less than 10 keV, energy band are attributed to photoelectric absorption in the accretion flow. In contrast, the complex absorbers may be responsible for producing low-amplitude spin modulations via Compton scattering in the hard, greater than 10 keV, energy band, indicating that the height of the X-ray emitting region may be negligible. The observed double-humped X-ray profiles with a pronounced dip are indicative of photoelectric absorption in the intervening accretion stream. Analysis of the X-ray spectrum reveals the complexity of the X-ray emission, being composed of multi-temperature plasma components with a soft excess, reflection, and suffering from strong absorption. The authors discuss the accretion mechanisms in intermediate polars, including disk-fed, diskless, and discover flow accretion. In disk-fed accretion, strong modulations are expected to occur at the white dwarf spin frequency. In contrast, in pure stream-fed systems, the beat frequency is dominating. For discover flow accretion, modulations at both spin and beat frequencies are expected to occur, and the main difference lies in the varying power, amplitude between the two. The paper highlights the importance of analyzing multiple periodicities in the X-ray and optical bands to determine the intermediate polar nature of a potential member of this class. The research paper delves into the X-ray emitting intermediate polar, IP, IGR 1509, first discovered by Integral, IBIS in the 1760 keV energy range. Optical spectroscopy and photometric observations have classified this system as an IP, with a spin period of 809.424 seconds and an orbital period of 5.89 hours. The presence of strong circular polarization suggests that IGR 1509 has an extended accretion curtain, possibly related to either polars or soft X-ray emitting IPs. The paper presents a detailed analysis of archival optical and X-ray observations, including data from TESS, Suzaku, and NuSTAR. TESS observations were conducted in sectors 12, 38, and 39, with a cadence of 2 minutes, providing uninterrupted high-cadence light curves crucial for probing the true nature or accretion geometry of IGR 1509. X-ray observations include Suzaku and NuSTAR data, which were used to fit the PSR X-ray spectral model and derive the white dwarf mass of 0.73 plus or minus 0.06 m. The paper aims to understand the accretion geometry of IGR 1509 by analyzing the beat period, which was not clearly detected in earlier studies. The analysis of the optical and X-ray data is crucial for unveiling the nature of IGR 1509 in greater detail and understanding its true accretion geometry. The long-term light curve of IGR J15094-6649, a disk-dominated intermediate polar in an X-ray binary system, is the focus of this research. Multi-source data, including AAVSO, ASASSN, and TESS observations, were analyzed to investigate the system's variability. The light curve in Figure 1a reveals significant fluctuations over time, potentially indicative of changes in the accretion rate or system geometry. The full TESS light curves for sectors 12, 38, and 39, presented in Figure 1b, show the mean flux of each day, represented by red dots. A zoomed-in view of 2 consecutive days of TESS observations, Figure 1c, highlights the system's rapid variability. To process the TESS data, the authors utilized PDCSAP data, which has been corrected for instrumental systematic variations. Only high-quality data points with quality flag equals 0 were considered in the analysis. In addition to TESS data, long-term light curves from the ASASSN and AAVSO databases were collected, covering observations between 2007 and 2019. The combination of these datasets provides a comprehensive understanding of IGR J15094-6649's long-term variability. Analyzing this variability is crucial for understanding the accretion mechanisms and system geometry, contributing to the ongoing study of X-ray binaries and their variability. The research paper presents a comprehensive analysis of IGR 1509, a hard X-ray pulsar, utilizing data from Suzaku and NuSTAR X-ray observations. The study's primary objectives are to determine the source's spin and orbital periods, as well as its spectral properties. TESS observations were conducted in sectors 12, 38, and 39, resulting in the generation of LS power spectra, Figure 2. These spectra provide insights into the source's spin period. Spin pulse profiles with a phase bin of 0.02 are presented in Figure 3, shedding light on the source's spin period. Suzaku X-ray observations were carried out on January 27, 2011. Data reduction involved the use of specific software and calibration files to generate light curves and spectra. The data was grouped to have at least 20 counts per bin for spectral analysis. HXDPIN data underwent dead-time correction, and the cosmic X-ray background was subtracted from the source spectrum. NuSTAR observations were conducted on July 19, 2018. The data was processed using the NuSTAR data analysis software, and science quality events were reprocessed with updated calibration data. Light curves and spectra were extracted from circular regions around the source and background, considering the astrometric offset between the FPM-A and FPM-B modules. Barycentric corrected light curves, spectra, effective area files, and response matrices were obtained using the /n.pc/u.pc/r.pc/o.pc/d.pc/u.pc/c.pc/s.pc package. The paper concludes with the presentation of the group spectra for further analysis, emphasizing the significance of these observations in understanding the properties of IGR 1509. By utilizing both Suzaku and NuSTAR data, the study offers a comprehensive examination of the source's spin and orbital periods, as well as its spectral properties, which will be discussed in subsequent sections of the paper. Figure 4 presents time-resolved power spectra from TESS observations of the disk-dominated intermediate polar IGR J15094-6649, resolved into 3 panels for sectors 12, 38, and 39, showcasing variability in the omega, and 2 omega frequency region. In sector 12, a prominent peak at operator 1.4 mHz is observed, accompanied by a harmonic at operator 2.8 mHz, with a red noise component in the power spectral density, PSD, indicative of stochastic variability. Similarly, sector 38 exhibits a prominent peak at operator 1.1 mHz, accompanied by a weaker harmonic at operator 2.2 mHz, with a red noise component in the PSD. Sector 39 features a prominent peak at operator 1.3 mHz, with a harmonic at operator 2.6 mHz, and a PSD that combines red and white noise components. These power spectra are crucial for characterizing the variability of IGR J15094-6649, allowing for the identification of periodic and stochastic components. The resolution of the power spectra into distinct frequency regions enables the examination of variability at different timescales. The presence of harmonics and subharmonics suggests complex variability patterns, warranting further investigation. The analysis presented here builds upon previous sections, which established the disk-dominated nature of IGR J15094-6649. The subsequent sections will explore the implications of these findings and their broader context in accretion-powered binaries. The neutron star system IGR 1509 was analyzed using observations from the TESS, Suzaku, and Swift telescopes, revealing a variable source with periodic behavior in its light curves. The Lomb-Scargill periodogram algorithm was applied to TESS data from sectors 12, 38, and 39, detecting 6 dominant peaks in the power spectrum corresponding to frequencies omega, U, omega, 2 omega, 3, omega 2 ohms, and 3 omega. The significance of these peaks was determined by calculating the false alarm probability. Swift observations of IGR 1509 were conducted on 3 occasions, with exposure times of 0.3 kiloseconds, 0.7 kiloseconds, and 6 kiloseconds. The background was selected from a nearby source-free region of similar size to the source, and an ancillary response file was calculated to correct for count losses due to hot columns and bad pixels using exposure maps. A comprehensive table summarizes the periods corresponding to the dominant peaks in the power spectra of IGR 1509, obtained from the LS periodogram analysis of TESS, Suzaku, and Swift observations. Figure 5 presents the evolution of the spin pulse profiles during TESS observations for sectors 12, 38, and 39, showcasing the periodic nature of the light curves. The timing and spectral analyses of IGR 1509 using data from TESS, Suzaku, and Swift telescopes highlight the detection of multiple frequencies in the power spectra and their significance. The evolution of the spin pulse profiles observed during the TESS observations provides valuable insights into the system's behavior. The results of this study contribute to a deeper understanding of neutron star systems and their complex variability. The X-ray binary system IGR J15094-6649 exhibits complex variability patterns in both X-ray and optical bands. Analysis of data from the TESS and Suzaku missions reveals periodic variations in the system's X-ray and optical emissions. The TESS data shows a prominent spin frequency of 809.49584 seconds, along with its harmonics and sidebands, indicating a complex modulation pattern. This spin frequency is consistent with the periodic variability observed in the power spectra and is further supported by the spin phase folded light curves, which display a broad hump during one rotation of the white dwarf. The analysis also reveals a strong one-day periodicity, attributed to the system's orbital period. Suzaku observations confirm similar periodic patterns in the power spectra, with the spin frequency and its harmonics being significant in all energy bands. Notably, a period corresponding to p omega squared equals 1627.2 plus or minus 8.9 seconds is detected in the 610 keV energy band, which is not observed in the TESS data. This suggests a possible connection to the system's orbital period. Energy-dependent periodic variations were inspected in 3 energy bands using XISFI observations. The spin pulse profiles obtained from these observations are consistent with the periodic variability observed in the power spectra. The detected periodicities are consistent with the spin period of the white dwarf and the system's orbital period, providing insights into the complex modulation patterns of IGR J15094-6649. These findings highlight the importance of multi-wavelength observations in understanding the properties of X-ray binary systems. The X-ray power spectra obtained from the Suzaku XISFI observations, as depicted in Figure 7a, exhibit significant peaks at the spin frequency omega and its harmonics 2 omega and 3 omega. These peaks decrease in power towards harder energy bands. The energy-dependent X-ray spin pulse profiles extracted from the XISFI observations, shown in Figure 7b, display double-peaked spin modulations that are more prominent at lower energies and almost constant at higher energies. The spin phase folded hardness ratio curves, HR1 and HR2, also show strong modulation and are 180 degrees out of phase with respect to the intensity modulation. The degree of spin pulsations is estimated using the formula I_max I_min, I_max plus I_min, times 100%. Where I_max and I_min are the maximum and minimum intensities in a pulse profile, respectively. The derived values of the pulsed fraction are given in Table 3, which reveals a decreasing trend as the energy increases. The NuSTAR observations, analyzed in the 378 keV energy band, exhibit three significant periods corresponding to the frequencies omega, 2 omega, and 3 omega in the combined light curve, figure 6b. These periods are consistent with those derived from the TESS and Suzaku observations. The NuSTAR power spectra, figure 8a, also exhibit a marginal detection of the X-ray beat frequency, consistent with the optical beat frequency derived from the TESS observations. The periods corresponding to the frequencies omega, omega omega, 2 omega, and 3 omega in the 378 keV energy band are given in Table 2. A significant peak is observed near the 47-1 frequency region, corresponding to a period of 1822.1 plus or minus 11.3 s, with no possible relation to other present frequencies found in the power spectrum. Four other periods, which are a combination of the spin and orbital frequencies, are also seen in the NuSTAR power spectra. These periods are p underscore omega 3 ohms equals 937.2 plus or minus 2.9 s, p underscore omega plus 3 ohms equals 713.7 plus or minus 1.7 s, p underscore 2 omega 3 ohms equals 435.2 plus or minus 0.6 s, and p underscore 2 omega plus 3 ohms equals 379.0 plus or minus 0.5 s. Analysis of the Lomb-Scargill X-ray power spectra, derived from the NuSTAR observations of IGR J15094-6649 in multiple energy bands, reveals the presence of several frequency peaks, most prominently omega, omega 3 ohms, omega plus 3 ohms, 2 omega, 2 omega 3 ohms, 2 omega plus 3 ohms, and 3 omega. Figure 8 shows that the horizontal dotted lines represent the 95% confidence level, establishing significance. Notably, Figure 8b exhibits energy-dependent X-ray spin pulse profiles across different bands and displays corresponding hardness ratio curves, including HR3, which measures count rate ratios from the 610 keV to the 36 keV energy band, and HR4, defined by ratios between 1030 keV to 610 keV energy bands. Results illustrate that hardness ratios, especially in HR3 and HR4, undergo modulations opposite those found in the overall pulse intensities, consistent across studied energies. Evidence reveals X-ray modulation spanning all band assessments featured, and when collectively presenting tables, note various fractional dependencies due explicitly bands available below provided numbers resulting several measurement patterns compared. Best combined descriptions beyond variation is what figure from larger over simple reference context key identified subterm reveals statistical for related amplitudes correlation further both through emission effects. Relative faint structure details matter examined or have set dependence times like source form radiation, while strength associated near significantly trends mapped components while having so do allow variability dependent stronger result have major. This discussion and opportunity current present measurement like band here dependent case relation indicate additional description features. Non-aligned event forms lead those double peaks exhibit no relevant mean stronger total measurements comparison present cross correlate description faint dependency associated lead by changes specific leading increase remain directly corresponding of relatively varied present non-vary most nearly forms still depend do even noted differences having light near overall is component response multiple shorter which measurement point would however confirm comparison on would IGR different trend only based available if components vary suggest double set total short first study less large however well likely generally modulation strength will major discussed possible now seen just found it explained could cross-examine follow increase magnetic sum. Many modulate such only harder single strength those specific variations such described variability detailed difference affects dependency modulations peak study if high while depend event HR those peaks it described what general comparison related depend others although spin large phase stronger times during explain seen leading then having like through bands evidence provide could table indication softer describe follow reference measured structure having shown at ratio possible just however much possible at intensity variable overall difference best many well relatively weak X here trends difference indication 1 confirmed during effect description specific radiation less which allow same while overall such larger. Most HR such first many do measure power all corresponding case clearly components similar. The energy-dependent periodic variations in the X-ray emission of IGR 1509 are investigated using Swift observations. The LOM-Scargill X-ray power spectra in the 0.310.0 keV, 0.33.0 keV, 36 keV, and 610 keV energy bands exhibit several periodic features, including omega-3 ohms, omega plus 3 ohms, 2 omega-3 ohms, 2 omega, 2 omega plus 3 ohms, and 3 omega. The corresponding periods are calculated as p omega-3 ohms equals 937.3 plus or minus 6.4 s, p omega plus 3 ohms equals 709.0 plus or minus 3.6 s, p2 omega-3 ohms equals 435.8 plus or minus 1.4 s, and p2 omega plus 3 ohms equals 378.0 plus or minus 1.0 s. The energy-dependent X-ray spin pulse profiles in the 0.33.0 keV, 36 keV, and 610 keV energy bands show strong modulations in the softest energy band. The spin phase folded hardness ratio curves, HR5 and HR6, are derived, with the HR5 curve varying anticorrelated with intensity modulation, and no significant variations in the HR6 curve. The degree of pulsations is calculated from the Swift light curves, with fractional amplitude modulations decreasing from 91 plus or minus 13%, 0.33.0 keV, to 41 plus or minus 16%, 36 keV, energy bands, and no significant periodic variation detected in the 610 keV energy band. X-ray spectral analysis is performed using Suzaku observations in the 0.310.0 keV and 1250 keV energy bands. The background subtracted X-ray spectra exhibit a strong broadband continuum along with complex iron emission line features. Spectral fitting is accomplished using XSpec version 12.12.0, with models similar to those used by Bernardini et al. 2012 for the XMM Newton data, but with updates to the interstellar absorption model, PCF-ABS model, and Macau model. A constant model component is included to account for cross-calibration uncertainties between instruments. The abundance tables and photoelectric absorption cross-section, BCMC, are taken from the Suzaku Memo 2008066. The X-ray spectra of IGR J15094-6649, obtained from Suzaku XIS, PIN, Swift XRT, and NuSTAR FPMB, are presented in Figure 10. These spectra were fitted using three models. A, B, and C. Model A includes a constant, FABS, PWAB, blackbody, MKC flow, and Gauss components. The redshift was fixed at 2.55 times 10 carat 7, for a Gaia distance of 1091 plus or minus 25%. With the low temperature of the MKC flow set to the minimum value allowed by the model, 80.8 electron volts. The switch parameter was set to 2, determining whether the spectrum is computed using the AtomDB data. The equivalent hydrogen column from the FABS model was fixed to the total galactic column in the direction of IGR 1509, 1.89 times 10 to the 21 cm carat 2. Model A provided a good fit to the spectra, with a chi-2, nu of 1.06. The large equivalent width, EU, of the Phi-K alpha emission line and the column density of cold matter were found to be higher than 2 times 10 to the 23 cm carat 2, suggesting that the bulk of the Phi-K alpha emission line can be accounted for by the absorbers, while there may also be a contribution from a Compton reflected continuum from the white dwarf. Model B includes a convolution model reflect to account for the reflected continuum of the plasma emission due to the Phi-K alpha at 6.4 keV. However, the value of the reflection scaling factor, R_refl, was derived to be more than unity, which is not physical. Therefore, this parameter was fixed to unity, allowing cos I to vary as Model C. Model C provided fits with a similar quality as the best fit value cos I less than 0.30. The unabsorbed X-ray flux in the 0.350.0 keV energy band was calculated using the CFLUX model. The best fit parameters for each model are given in Table 4. with error bars quoted with a 90% confidence limit for a single variable parameter. The Swift and NuSTAR spectral fits were also investigated, and the results are consistent with the Suzaku spectral fits. A large EU of the Phi-K alpha emission was observed, similar to the Suzaku results. The iron line complex region is also seen in both the Swift and NuSTAR spectra. The results suggest that the X-ray spectra of IGR J15094-6649 can be well fitted using a combination of absorption and emission components, including a Compton-reflected continuum. The large EU of the Phi-K alpha emission line and the column density of cold matter indicate that the absorbers play a significant role in shaping the X-ray spectra. The research paper presents a comprehensive analysis of the optical and X-ray properties of an intermediate polar, IP, IGR J15094. Utilizing observations from the Transiting Exoplanet Survey Satellite, TESS, and X-ray data from Suzaku, Swift, and NuSTAR, the study reveals three prominent frequencies at omega, 2 omega, and 3 omega in the TESS light curves, consistent with previous findings. A refined spin period of 809.49584 plus or minus 0.00075 seconds is also determined. The spectral fitting of the Suzaku XIS and contemporaneous Swift and NuSTAR observations for the 2011 and 2018 epochs employ three models. A, B, and C. Model A includes a power law and blackbody components, while Model B adds a reflect model to account for X-ray reflection and iron line complex. Model C, which allows the cosine of the inclination angle, cos-I, to vary, provides the best fit for both epochs, with a better fit for the 2018 data. The unabsorbed X-ray fluxes were calculated for the 0.310.0 keV and 0.378.0 keV energy bands for the Suzaku XIS and contemporaneous Swift and NuSTAR spectra, respectively. The spectral parameters obtained from the best fit models for the average Suzaku and contemporaneous Swift and NuSTAR observations are presented in Table 4. The spectral fitting of the Suzaku XIS and contemporaneous Swift and NuSTAR spectra at pulse maximum 0.81.0 and pulse minimum 0.50.7 phases was performed using the best fit Model C. The resulting spectral parameters are summarized in Table 5. The presence of an unambiguous U frequency in the optical band, with a marginal detection in X-rays, suggests that this modulation seems intrinsic, originating from the accretion through the stream. The omega and 3, omega 2 ohms, frequencies are also detected in the power spectrum. In the realm of X-ray astronomy, intermediate polar, IP, IGR J15094-6649 has been subject to a comprehensive investigation. This study delves into its X-ray and optical power spectra, revealing strong spin modulations indicative of a disk-fed accretion process. The absence of orbital modulation in X-rays is anticipated, as it is typically confined to soft energy bands in IPs. Multiple sideband frequencies at thrice the orbital frequency, specifically 3 omega omega, 3 omega plus omega, 2, 3 omega omega, and 2, 3 omega plus omega, are identified, suggesting amplitude modulation of the fundamental frequencies. Orbital modulation may result from photoelectric absorption in infalling material or the eclipse of a hotspot by the disk, akin to X-ray absorption effects described in Rosen et al. 1988. Non-detection in X-rays might imply it occurs mainly at softer energy bands, characteristic of IP modulations. IGR 1509 exhibits the signature feature of IP, displaying a prominent X-ray modulation at its spin frequency due to either absorption effects from material inflows or emission occultations from WD magnetic pole alignments. Rosen 1992. Both soft X-ray is less than or equal to 10 keV, energy dependence of observed modulation, coupled with observed intensity harmonicity in intensity anti-correlated modulation ratios at stronger, minimum, yields good coherence of such systems conforming with well-tested, accretion curtain model. Rather consistent accretion channel arrangements having prior identification like several different interpretations being likely overrode. The authors of the study present their conclusions on the intermediate polar IGR J15094-6649. Drawing from Suzaku, Swift, and NuSTAR observations. The analysis reveals a large absorption component at the pulse minimum phase and a small absorption component at the pulse maximum phase, consistent with the classical curtain scenario. This phase-dependent variability is also observed in fluorescent emission line components. Notably, these components exhibit lower values during the 2011 Suzaku observations compared to the 2018 Swift and NuSTAR observations, possibly due to a different viewing angle onto the accretion column or variable abundance of the ambient medium. Key findings include the detection of a precise spin period and orbital period using TESS observations, the detection of an unambiguous beat period, and the suggestion that IGR J15094-6649 might be accreting predominantly via a disk, but with part of the accreting material flowing directly toward the white dwarf along the magnetic field lines. Photoelectric absorption is identified as responsible for the soft X-ray modulation, while complex absorbers may produce low-amplitude spin modulations via Compton scattering in the hard energy band. The X-ray spectra can be explained by a multi-temperature plasma component, intrinsic absorption, reflection, and a soft component. The soft X-ray blackbody temperature is found to be in the range of 8090 electron volts, classifying this system as a soft IP. The estimated blackbody emitting area covers approximately 10 to the power of 5 of the white dwarf surface. The authors acknowledge the contributions of various teams and archives, including the TESS mission, the Suzaku team, the NuSTAR mission, and the AAVSO International Database. The data used in this study are publicly available in the NASA's High Energy Astrophysics Science Archive Research Center, HEASARC, archive and the TESS Data Archive. Intermediate polars, or IPs, are a subclass of magnetic cataclysmic variables that provide unique insights into accretion processes. The disk-dominated IP J15094-6649, with its high luminosity and long orbital period, is an intriguing subject for investigation. To analyze its X-ray properties, observations from the XMM Newton and Swift telescopes were utilized. The data reduction process involved calibrating and filtering the data to obtain high-quality X-ray spectra and light curves. Spectral analysis revealed a strong iron emission line, indicative of a high-density plasma. This line is attributed to the accretion flow being channeled along the magnetic field lines, resulting in a high-velocity shock near the white dwarf surface. The X-ray light curves exhibited a prominent modulation at the orbital period, suggesting that the X-ray emission is influenced by the viewing geometry of the system. This modulation is interpreted as evidence of an accretion curtain, a characteristic feature of IPs. Furthermore, a shorter period modulation was detected, attributed to the spin period of the white dwarf, supporting the classification of J150,946,649 as an IP. The implications of these findings are significant for our understanding of accretion processes in IPs. Continued monitoring of J150,946,649 is crucial to further understand its behavior and the underlying physics of magnetic cataclysmic variables. This study contributes to the understanding of the X-ray properties of IPs, particularly J15094-6649, by analyzing its X-ray spectra and light curves. The detection of a strong iron emission line and modulations at the orbital and spin periods provide valuable insights into the accretion processes in this disk-dominated IP.